Artificial intelligence has made remarkable progress in recent years, and large language models, LLM, have been leaders in understanding, reasoning, and creative expression of natural language. However, despite their capabilities, these models still rely entirely on external feedback for improvement. Unlike humans, who learn by reflecting on their experiences, recognizing mistakes, and adjusting their approach, LLMs lack an internal self-correction mechanism. Self-reflection is fundamental to human learning. It allows us to refine our thinking, adapt to new challenges, and evolve. As artificial intelligence approaches the most important species, known as artificial general intelligence, AGI, the current reliance on human feedback is proving to be resource-intensive and inefficient. For AI to evolve beyond static pattern recognition toward a truly autonomous and self-improving system, it must not only process large amounts of information, but also analyze its performance, identify its limitations, and refine its decision-making. This shift represents a fundamental transformation in AI learning, making self-reflection a crucial step toward more adaptable and intelligent systems. Main challenges faced by large language models today. Existing large language models, LLMs, operate within predefined training paradigms and rely on external guidance, usually human feedback, to improve their learning process. This dependence restricts their ability to adapt dynamically to changing scenarios, preventing them from becoming autonomous and self-improving systems. As LLMs evolve into AI systems with agents capable of autonomous reasoning in dynamic environments, they must address some key challenges: lack of real-time adaptation. Traditional LLMs require periodic training to incorporate new knowledge and enhance their reasoning capabilities. This makes them slow to adapt to constantly evolving information. LLMs struggle to keep pace with dynamic environments without an internal mechanism to refine their reasoning. Inconsistent accuracy. Since LLMs cannot analyze their performance or learn from past mistakes independently, they often repeat errors or do not fully understand the context. This limitation could lead to inconsistencies in their responses, reducing their reliability, especially in scenarios not considered during the training phase. High maintenance costs. The current approach to improving LLMs involves extensive human intervention, requiring manual supervision and costly training cycles. This not only slows progress, but also demands significant computational and financial resources. The need to understand self-reflection in AI, self-reflection in human beings, is an iterative process. We examine past actions, evaluate their effectiveness, and make adjustments to achieve better results. This feedback cycle allows us to refine our cognitive and emotional responses to improve our decision-making and problem-solving skills. In the context of artificial intelligence, self-reflection refers to a large language model's, LLM, ability to analyze its responses, identify errors, and adjust future results based on acquired knowledge. Unlike traditional AI models, which rely on explicit external feedback or retraining with new data, self-reflective artificial intelligence actively evaluates its knowledge gaps and improves through internal mechanisms. This shift from passive learning to active self-correction is crucial for making AI systems more autonomous and adaptable. How self-reflection works in large language models. Although self-reflective AI is in the early stages of development and requires new architectures and methodologies, some emerging ideas and approaches include recursive feedback mechanisms. Artificial intelligence can be designed to review previous responses, analyze inconsistencies, and refine future results. This involves an internal loop where the model evaluates its reasoning before presenting a final answer. Memory and context tracking. Instead of processing each interaction in isolation, artificial intelligence can develop a memory-like structure that allows it to learn from past conversations, improving coherence and depth. Uncertainty estimation. Artificial intelligence can be programmed to assess its confidence levels and flag uncertain responses for further refinement or verification. Meta-learning approaches. Models can be trained to recognize patterns in their errors and develop heuristics for self-improvement. Since these ideas are still in development, AI researchers and engineers are continuously exploring new methodologies to improve the self-reflection mechanism for LLMs. While early experiments are promising, significant efforts are needed to fully integrate an effective self-reflection mechanism into LLMs. How self-reflection addresses the challenges of LLMs, large language models' self-reflective artificial intelligence can enable master's students to become autonomous and improve their reasoning without constant human intervention. This capability can offer three fundamental benefits that can address the key challenges faced by master's students. Real-time learning. Unlike static models that require costly retraining cycles, self-evolving LLMs can update themselves as new information becomes available. This means they stay current without human intervention. Greater accuracy. A self-reflection mechanism can refine the understanding of LLMs over time. This allows them to learn from previous interactions to create more precise and contextually appropriate responses. Reduce training costs. Self-reflective artificial intelligence can automate the LLM learning process. This can eliminate the need for manual retraining, saving companies time, money, and resources. Ethical considerations of self-reflection in artificial intelligence. While the idea of self-reflective LLMs is very promising, it raises significant ethical concerns. Self-reflective AI can make it difficult to understand how LLMs make decisions. If AI can autonomously modify its reasoning, understanding its decision-making process becomes a challenge. This lack of clarity prevents users from understanding how decisions are made. Another concern is that artificial intelligence could reinforce existing biases. AI models learn from large amounts of data, and if the self-reflection process is not carefully managed, these biases could become more prevalent. As a result, mastery in law could become more biased and inaccurate rather than improved. Therefore, safeguards are essential to prevent this from happening. There is also the issue of balancing artificial intelligence autonomy with human control. While AI should be corrected and improved, human oversight must remain crucial. Excessive autonomy could lead to unpredictable or harmful outcomes, so finding a balance is essential. Finally, trust in artificial intelligence could decrease if users feel that AI is evolving without sufficient human involvement. This could cause people to be skeptical of its decisions. To develop responsible AI, these ethical issues must be addressed. Artificial intelligence should evolve independently, but at the same time, it must be transparent, fair, and accountable. The end result. The emergence of self-reflection in artificial intelligence is changing the way large language models, LLMs, evolve, shifting from reliance on external inputs to becoming more autonomous and adaptable. By incorporating self-reflection, AI systems can improve their reasoning and accuracy and reduce the need for costly manual retraining. While self-reflection in LLMs is still in its early stages, it has the potential to create a transformative change. LLMs that can assess their limitations and make improvements on their own will be more reliable, efficient, and better suited to tackle complex problems. This could significantly impact various fields such as healthcare, legal analysis, education, and scientific research, areas that require deep reasoning and adaptability. As self-reflection in artificial intelligence continues to develop, we might see LLMs that generate information and critique and refine their own results, evolving over time with little human intervention. This shift will represent a significant step toward creating smarter, more autonomous, and reliable AI systems.